Okay, so we are going to go over your Unit 7 test review. Your test is going to be on Wednesday, so make sure you prepare. A couple things before we start. So, probability, which is what the unit is about, you get it by putting your part that you want. Okay, so you look at the question and you see what you want, put that number up there, and then put it over the total every time. After you do that, you will simplify or reduce whenever needed. So if needed, you go ahead and simplify. Another thing, make sure you use labels. Labels help. So give the names of what you're looking for so that way you can put the number in the correct spot, whether on top or bottom. And then the last thing, when you're making a prediction, you want to use a proportion to solve. I know in my class I say line equals line and they know what I'm talking about. So basically, and then you put your labels and then you put your numbers. To solve that, you will cross multiply and then divide. So let's get started. Number 1 says, how many times can Hayshawn expect to roll a 2 if he rolls a fair number cube 132 times? So first thing is you see the word expect, so that means you're going to predict. Okay, so whatever you expect to happen, so that's a prediction. So we're definitely going to use a proportion. And real quick, a fair number cube has 6 numbers total on it. Okay, so we are going to use proportion since we are predicting from the word expect. So okay, like I told you before, try and make sure you use labels. So it's going to be the part that you want. Well, they say they want to expect whether he rolls a 2. Okay, so I'm going to write roll a 2. Okay, that's the part that I want that will go on top over the total. Okay, so how many times can you roll a 2 if you're rolling a fair number cube? Well, there's only 1 2 on the cube, so you can only roll it 1 time out of a total of 6 numbers. Okay, 1 2 3 4 5 6, that is 6 numbers, and I can roll a 2 once. Then you have your 132. Okay, you're going to roll it 132 times, and so that'll be your total. Okay. And then you want to see how many times will you roll a 2 out of that, so that'll be a variable. I'll just choose X. To solve a proportion, you would just cross multiply, meaning multiply diagonally. Okay. You can do it 2 ways. You can multiply both ways to where, okay, 132 times 1 is 132. And then 6 times X, you just put it together and say it's 6X. Then I'll put a line on my equal sign. I want to get X by itself. So right now they are multiplying. So I do the opposite. The opposite of multiplication is division. And I will divide by the number that I want to leave, which is the 6. This side cancels out, so you're left with X equals, and then 132 divided by 6, you will find out it equals 22. Number 2 says the spinner is divided into 8 equal sections. Here it is. What is the probability that the spinner will land on a green section? So usually I'll underline exactly what they want in the question, so that way I know what I'm looking for when I make my probability. Okay, so we see that our answer choices are percents, and so we want to get from here to a percent. So I've written that to get a percent, you must start with a fraction. Okay, so you'll start off with a fraction, And then to get to a decimal, you'll do that by division. If you were in 6th grade, I know we used Nerd and Donkey last year if you were here. So that's what you would do to get the decimal. And then to get to the percent, you will move the decimal to the right twice. You must move your decimal. Do not leave it there. So we want to get a green section. So all we do is we'll count the green. So there's 1, 2. Okay. So the part that I want is green over my total. So there are 2 green out of a total of 8 sections. And I want to go straight to a percent, so I'm going to go ahead and divide to get my decimal. So Nerd and Donkey, that basically means your 2 will go on the inside because it's on top. Your 8 will go on the outside. And you will end up with 0.25 as your decimal. But then you want a percent. You don't want to stay at the decimal. So you must move your decimal to the right twice. So you have 0.25. We used to use Dr. Pepper just to show that it will go to the right and it will go twice. So 1 for the 2 and 1 for the 5. So the decimal ends up behind the 5. So you'll end up with 25%. Number 3, Josephina lives on a farm with 3 sheep, 2 goats, 11 chickens, and 5 cows. She is going to randomly select an animal to take to the stock show. What is the probability of randomly selecting a cow or a goat? So I will underline what I want. I want a cow or a goat. So what that means is we're going to count the cows and the goats and put them together as our numerator. So I'm going to put cow or goat on top and then over my total. So cow or goat, well, there are 5 cows and 2 goats. So cows and goats will go together. So 7 over my total. Well, they didn't give me my total, so I have to add. So 3 plus 2 is 5, plus 11 is 16, plus 5 is 21. So I see that I can simplify. Okay, there is a number that goes into both of those. So I'm going to simplify. I can simplify by 7. So simplify just means divide by the same number. 7 divided by 7 is 1. 21 divided by 7 is 3. So I get an answer of 1 over 3. Or 1/3. Okay. As far as my decimal, if I wanted to get a decimal, remember we would just divide. So Nerd over Donkey, which just basically means that the 1 will go on the inside because it's on top and 3 will go on the outside. If I divide, you will see that it repeats. And so to say that it repeats, I will just write the number that I have and say it repeats by putting a line on top of my 3's. Okay, so if I wanted to get a decimal from the fraction, I would just divide. So, number 4, a spinner is divided into 24 equal parts. The probability of spinning an X is 1 out of 3 or 1/3. How many of the parts are labeled X? So I will underline what I want so I don't forget. We're looking for X, and so I'll put the part that I want on top. So I'll just say I want an X, and then it's always going to be over the total. Okay, and for this will be total parts. So On this one, I'm going to end up using a proportion. The reason why I know, usually if they give me a set 3 numbers and I'm looking for a fourth, I will use a proportion to get there. Okay, so I have a 24, a 1, and a 3. I'm looking for the fourth one. And so that's another way you can use a proportion. Okay, the first way is if I saw the word expect or predict. This way is because I see 3 numbers, right? 24, 1, and 3, and I need a fourth one. Okay, so all right, so what we have is the probability of spinning an X is 1 out of 3, so 1 out of 3. And then our other number is that there are 24 equal parts. Well, the 24 is going to go on the bottom. I'm looking for how many of the parts are labeled X, and so this is going to be the variable. Okay, so we'll cross multiply. Another way you do it is 24 times 1 is 24. And then you automatically know you're going to divide by the number that is left. So 24 will go on the inside, divided by 3. 3 goes into 24 8 times to get 24. Okay, so that's another way you can get it done. All right, so your answer is 8. Number 5 says, on Roberto's shelf are 6 mystery books, 5 science books, 4 history books, and 3 adventure books. Roberto will randomly choose one book to read. What is the probability that he will choose an adventure book? So I'm going to underline what I want. Okay, so we're going to do adventure. That's the part that we want. So I'll put that on top. Always goes over total. Okay, so we'll just count how many adventures we have. So it's going to be 3, and then our total. All we would do is add, since they didn't give it to us. So 6 plus 5 is 11, plus 4 is 15, plus 3 is 18. Okay, and then you see that you can simplify because there is a number that goes into both of those evenly without getting a decimal. That number is 3. Just so you know, you would never use 1 just because you'll get the same thing, so you'll still have to reduce. So you want to choose another number that won't get a decimal. Okay, and so your answer will be 1/6. Now, what if you wanted to choose adventure and then a mystery book? So you'll have 2 different actions going on. You'll choose one and then the other. The amount of actions you have means that's how many fractions you're going to have. So I'll choose 2 books. The first time I only chose 1, so I only had 1 fraction. Okay, then I simplified it. But this one I have 2 actions, and so I'm going to have 2 fractions. So fraction times fraction. This one will be for the adventure. This one will be for the mystery after I chose the adventure book. Okay, so for adventure, again, you just count what you have of adventure. You have 3 out of a total of 18. And then you chose a mystery. So you did not put the adventure book back. You kept it, so you didn't put it back. And so now there's only 17 books left. And then you would just say, okay, now how many mystery books can I choose? It would be 6. And then to multiply fractions, you just multiply across. So you would do 3 times 6, which is 9. And then 18 times 17, which you will end up with 306. Okay. Now, you're right there. The only thing is you can simplify because there is a number that goes into both of those evenly without getting a decimal. Okay, which is 9. So I'm going to divide the top and the bottom by the same number, which is 9. And you will get 9 divided by 9, which is 1, and 306 divided by 9, which is 34. Okay, so if you wanted to choose adventure and then mystery after you have kept the adventure, then you would end up with 1 over 34. Okay. Number 6. Jeremiah has a spinner with 6 equal sections, numbered 1 through 6. If Jeremiah spins the spinner 180 times, how many times can he expect to spin a number less than 5? Okay, so I see the word expect, so that's a prediction, so I can definitely use a proportion to solve this. Okay, they want a number that is less than 5, so that means we are not going to count 5, we just want everything that is smaller than 5. So I'm just going to write down what they want. And remember, that always goes over my total. Okay, so a number less than 5. And this is a spinner that is numbered 1 through 6. So a number less than 5. So I have, first of all, I'll start off with 1, 2, 3, 4, 5, and 6. A number less than 5. So that means it has to be 1, 2, 3, or 4. It cannot be 5 or 6. So there are 4 numbers less than 5. Okay, out of a total of, there were 6 numbers. Okay, and it is a proportion, so line equals line. And then you have your last number, which is 180. That's how many times he will spin it. Okay, so that will go on a bottom. Okay, so I'm looking for how many will be less than 5 out of 180. So to solve a proportion like the last time, you will cross multiply. Okay, so you would do 180 times 4. And you will get 720. Then you'll divide by the number that is left. If you do so, you will end up with 120. So x equals 120. Okay, remember there's 2 ways to solve proportions. Okay, you can either do it where you go ahead and cross multiply and then divide, or you can cross multiply both ways and then isolate your x. Number 7 says a spinner has 4 sections with equal amount of space. The sections are shaded red, pink, purple, and blue. Which of the following statements is true? Okay, so basically what I'm going to do is I'm going to go through each of these and then just find the probability for each and then see if the statement is true. Okay, so A says the probability of spinning a pink. Okay, well, that'll be 1 pink out of 4 total colors. So that'll be 1 over 4 for that. And then it is greater than not spinning a pink. Okay, so not spinning a pink means I'm counting everything other than pink. So 1, 2, 3 out of 4. Okay, and if I want to really compare and I don't know whether they are equal or not, or which one's greater, I can just turn them into decimals by dividing, and I will get 0.25, and this one will get 0.75. Okay, so 0.25 is not greater than 0.75, so the answer is not A. B says the probability of spinning a purple, spinning a purple will be 1 out of 4, which is 0.25. Is equal to not spinning a blue. So I'm going to count everything that's not blue. So 1, 2, 3 out of 4, which like before is 0.75. So they're saying those two are equal. It is not, so that is not the answer. C says the probability of spinning a purple. Purple is 1 color out of 4. Okay, which we already know from before is 0.25. Is equal to not spinning a blue. not spinning a blue, everything but blue. So 1, 2, 3 out of 4, which from before is 0.75. Those are not equal, so that is not the answer. D says the probability of spinning a blue. Okay, blue is 1 out of a total of 4. Is less than not spinning a pink. So we're going to count everything that is not pink. So 1, 2, 3 out of 4. Okay, and then the decimals after dividing. They said that this probability is less than this one, and that is true. So D would be the answer. Okay. Number 8 says, in an online survey, a school learns that 77 of 100 parents prefer to receive the newsletter electronically. How many paper newsletters would the school estimate are needed if there are 650 parents? Okay, well, I'm going to use a proportion because I do see 3 numbers. So if I see that and I'm looking for a fourth, I can definitely use a proportion. But like I always do, I'm going to start off with labels. Please make sure you always use those. So newsletters, right? That's what they want. And that'll always be over my total. Okay, so I'm using a proportion. So line equals line. All right. So 77 out of 100 prefer to receive newsletters. So 77 prefer newsletters out of a total of 100. And then we have 650. So how many newsletters would the school estimate are needed if there are 650 parents? 650 must have to go on the bottom. And I want to know how many newsletters are needed out of that. So I'll put a variable there because that's what we are looking for. So we will cross multiply and divide. I will do it the other way this time. Okay, so 650 times 77 will give you 55,050 equals, and then 100 times x, we just put them together, so it's a 100x. Now I would get rid of my 100 by dividing. So divide both sides by 100 to get x by itself. This side cancels out, so x equals, and then I'd have to do 55,050 divided by 100. You will end up with 500.5. Now, that is technically correct, but you can't have half of a newsletter, okay, 0.5 of a newsletter. So what I'm going to do is go ahead and round to the nearest whole number. So 500.5, if I round it, will be 501, okay, and your decimal will be at the end if it's a whole number. So just make sure that you put your number in front of the decimal if it is a whole number, and then bubble it in for sure. Okay. Aramis wrote a fair 6-sided cube numbered 1 through 6 several times and recorded the data in the table below. So which statement is not true? Please make sure you do pay attention whenever it says not. Sometimes we forget that they said that. Okay, the main thing I'm going to start off with is odd numbers and even numbers because your answer choices have to deal with that. So just make sure you know your odd numbers are 1, 3, 5, 7, and all those. Keep skipping. And your even numbers will be 2, 4, 6. Keep going and keep skipping, okay? Another thing is that your outcome represents your theoretical probability, okay? So if you're looking for theoretical, you'll be looking on this side. Your frequency represents your experimental probability, okay? So if you're doing it with experimental, you would be looking on this side. And with the experimental, you always want to get the total, okay? How many times did you do that action, okay? And so once I added that, I automatically found the total for my frequency, which is 20. Okay, so if you add these, you should get 20. So make sure you do that for your experimental probability, because you would definitely have to put it over your total. Okay, so we're going to go through these and see which one is not true. So A says that the probability of rolling an odd number is greater than the experimental probability of rolling an even number. So experimental probability of rolling an odd number. Okay, so we're looking on this side. Okay, so an odd number would be 1, 3, and 5. So we're counting those ones. So I'm counting 6 plus 3, which is 9, plus 4, which is 13. Okay, and I counted how many 1s I had, how many 3s I had, and how many 5s I had. Okay, so 6 plus 3 plus 4 is going to be 13. And then out of my total, which is 20. Okay, and all I did was add those. Okay, and then you want the experimental probability of rolling an even number. So you're looking at your 2s, your 4s, and your 6s. Okay, and so it's going to be 4 plus 2 and then plus 1. And so that's going to be equal to 7 out of 20. So if I want to know which one's greater, I can get a decimal by dividing. Okay, and you will end up with 0.65 here, and then 0.35 here. Okay, so this is greater than this one, but we want what is not true, so that is not the answer because this one ends up being true. Okay, we want the one that's going to be false, so this one's true. All right, B says the experimental probability of rolling a 2. Okay, so we're just going to count the number of times that I rolled a 2, which will be 4. 4 out of my total, which is 20. Okay, and then if I divide that to get a decimal, I will get 0.2. Okay, now you want to do your theoretical probability of rolling a 2. So you're just looking on this side of how many times you can roll a 2, which will just be 1 time out of 6 numbers. And so that'd be 1/6. Okay, and so 1/6 is going to be equal to, if you divide it, 0.16, and the 6 is going to be repeating. So this is greater than 0.16, because if I do put a 0 here, 20 is bigger than 16. And so that is true. Okay, so we do not want what's true, we want what's false. C says the experimental probability of rolling an odd number. Okay, so you're counting your 1s, your 3s, and your 5s. So that'll be 6 plus 3 plus 4, which is going to be 13 over 20. And thankfully we did that before when we divided, which is going to give you 0.65. Now you're going to do your theoretical probability of rolling an odd number. Okay, so you're just looking on this side of how many times you can roll an odd number. So that'll be the 1, the 3, and the 5. So 3 times out of 6. Okay, so 3 out of 6. If we divide, you would get 0.5. Okay, they said that this number is greater than this number, and that is correct. So that is not the answer because it's true. Okay, and then D says the experimental probability of rolling a 6 is equal to the theoretical probability of rolling a 6. So experimental of rolling a 6. So we're going to just count how many times that I rolled a 6. That's going to be 1 time out of a total of 20. And the decimal, if I divide, is equal to 0.05. And you're going to compare that to the theoretical probability of rolling a 6. Okay, so That's going to be one time you can roll a 6 out of a total of 6 numbers. And so 1 out of 6, which is equal to 0.05. Actually, when you do 1 over 6, I'm sorry, you're actually going to get 0.16. And that 6 is going to be repeating, okay? And so they said it would be equal. It is not. And so that is the answer, because that was false, and that's what they wanted. They wanted what was not true, okay? Okay. We will continue in the next video.